All right, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So for the factoring, you should have x minus 10 times x minus 8. For the math knowledge question, it tells us that AC equals CB and OB is 7. What is the area in square centimeters? So if this is 7, that means that this other side is 7 because those are both a radius. And then this is also a radius, so it is 7. So we can use the area formula of a triangle where our base is 14 because 7 plus 7 is 14 and our height is 7. And if you multiply, you'll get 49 centimeters squared. So C would be your answer. Okay, so we are looking at lesson 29 today. We're going to look at using Pythagorean theorem. So hopefully after this lesson, you'll understand how to use the Pythagorean theorem. Whenever you have side lengths of your right triangle that are non-zero whole numbers that work for the Pythagorean theorem, you have a Pythagorean triple. One of the most common Pythagorean triples is 3, 4, and 5. There are infinitely many Pythagorean triples, but that is one of them. If you learn Pythagorean triples, or if you recognize them, then it'll make it so that you don't actually have to use Pythagorean theorem because you'll recognize, oh, those two, the third side length has to be this because it's a Pythagorean triple. A Pythagorean triple only has non-zero whole numbers for the side lengths. So if you have 2.4, then you will not have a Pythagorean triple because you don't have a whole number. So we want to find the unknown side here, and we want to know if it is a Pythagorean triple. So we're going to use Pythagorean theorem. 8 squared plus 15 squared equals d squared. So 8 squared is 64 plus 15 squared is 225 equals d squared. 64 plus 225 is 289. And then to find d, you take the square root. So the square root of 289 is 17. So that is the missing side length. So is this a Pythagorean triple? Yes. And why? All three side lengths are whole numbers. 8, 15, and 17 is another Pythagorean triple. So if you already knew that 8, 15, and 17 was a Pythagorean triple, then you wouldn't necessarily have needed to work this out because you would have known what the side length would be. We're going to look at another one. Find the unknown side length and do they form a Pythagorean triple. So a squared plus 12 squared is going to equal 15 squared. A squared plus 144 is going to equal 225. And then if you subtract, a squared will equal 81, and if you take the square root, that means that a would equal 9. So that's your missing side length. Do these form a Pythagorean triple? Yes. Why? Because all three side lengths are whole numbers. And this is actually a 3, 4, 5 multiplied by 3. So that's where the 9, the 12, and the 15 come from. So it's a base of 3, 4, 5 Pythagorean triple. Okay, now we're going to look at radical expressions. So on our math knowledge questions a couple of times, we have simplified radicals, and we're going to be doing that in this lesson. And so at this point on, for the rest of the year, if you have a radical, you need to make sure that it is simplified. So sometimes we're going to have right triangles that the side lengths are not all whole numbers. And so when that happens, we can have a radical expression. A radical expression is an expression that has the square root of a number. And it should always be reduced so that it is in simplified radical form. And so we'll practice that when we do some examples in just a second. So we want to find the value of our variables, and we want to simplify our radicals. So the first thing we need to do is set up Pythagorean theorem. So 6 squared plus 4 squared equals c squared. So that's going to be 36 plus 16 equals c squared. 36 plus 16 is 52. And then to find c, you're going to take the square root. So I've gone over this, but I'm going to go over it again. You factor this first. And if you know another way to simplify radicals, you can do that. I don't care, but this is how I think it goes best. 52 is 4 times 13, and 4 is 2 times 2. So instead of saying the square root of 52, I can say the square root of 2 times 2 times 13. We're going to take these pair of 2's and put them on the outside. And so that's going to become 2 square root of 13. And that would be c in simplified radical form. Okay, so now we're going to try b. If y'all want to try this one by yourself and then unpause the video, y'all can. So we're going to do 6 squared plus x squared equals 14 squared from Pythagorean theorem. So 6 squared is 36. And then 14 squared is 196. And so if you subtract, x squared is going to equal 160. So now we have to factor this, because when we take the square root, we want to simplify it. So 160 is 16 times 10, and 10 we know is 2 and 5. 16 is 4 and 4, which is 2 and 2, and 2 and 2. All right, so instead of writing 160, we're going to say the square root of 1, 2, 3, 4 2's, and then another 2 and a 5. So 1, 2, 3, 4, and then 2 times 5. And then remember, we have to have pairs. So here is a pair of 2's that we can pull out and take to the front. And then here's another pair of 2's that we can pull out and bring to the front. So 2 times 2 is going to be 4. And then we're left with square root of 10 on the inside. And so that would be the value for x. So that's how you can simplify your radicals. Looking at this one, we have the aspect ratio of a TV is 16 to 9, and the diagonal length is 62. We want to know what are the measures of the screen to the nearest tenth of an inch. So I'm going to start off by drawing the information they gave me. 62 is the diagonal. And then the aspect ratio, that means that we're going to have one side length that's going to be a 16 times some variable, and the other one is going to be 9 times some variable. And then from there, you're just going to use Pythagorean theorem. So we're going to do 16x squared plus 9x squared, and then that's going to equal 62 squared. So 16x squared is going to be 256x squared, and then 9x squared is going to be 81x squared, and then 62 squared is going to be 3,844. So if you combine your 256 and 81, you're going to get 337 x squared, and then equals 3,844. Then you're going to divide by 337. And that's going to give me that x squared equals 11.4. And so then we're going to take the square root of that number. and you should get that x is 3.377, and it keeps going. And then to find the dimensions of the screen, you're just going to multiply it by 16 and multiply it by 9. So that number times 16 is 54.0 inches. And then that same number times 9 is 30.4 inches. So that would be your answer. Okay, so let's see if y'all can do these two practice problems by yourself, and then unpause the video and I'll go over them. So if we are looking for the hypotenuse, we're going to do 20 squared plus 21 squared equals x squared. So 20 squared is 400, and 21 squared is 441. And if you add those together, you get 841 for x squared, and then you take the square root. So x would equal the square root of 841, which is 29. So is this a Pythagorean triple? Yes, because they're all three whole numbers. For the next one, we're going to use Pythagorean theorem again. So p squared plus 40 squared equals 41 squared. So p squared plus 1600 equals 41 squared is 1681. So if you subtract, p squared will equal 81. So when you take the square root, that means that p equals 9. So these are a Pythagorean triple because they all three are whole numbers. Okay? So let's see if y'all can try this one by yourself, and then once y'all are finished, unpause the video and I'll go over it. So we're going to use Pythagorean theorem. So 6 squared plus 14 squared equals s squared. So 36 plus 196 equals s squared. And if you add those together, you get 232 equals s squared. And then you take the square root. This, if you took the square root of it, is a decimal. So we need to factor it. So 232, I know it's divisible by 2 because it's an even number. So I get 2 and 1/16. That's also divisible by 2 because it's even. And then you get 58. And if you divide by 2, you get 29. And that's as far as you can factor it. So instead of writing 232, I'll write 2 times 2 times 2 times 29. We have one pair of 2's that can come out. And so that becomes 2 square roots of 58. And so that would be the value of s. Okay, looking at this next one, y'all try these by yourself, and then once y'all are finished, unpause your video and we'll go over them. So we're going to use Pythagorean theorem to find y. So the hypotenuse is the 20. So y squared plus 2 squared equals 20 squared. So y squared plus 4 equals 400. So y squared equals 396. And then you're going to take the square root of 396. So we want to factor 396. So 396 divides by 3 and gives me 132. And that divides by 2 to give me 66, which is 6 and 11. And that 6 is 2 and 3. So I have 2 times 2 times 3 times 3 times 11. So I have a pair of 2's and a pair of 3's that'll come out. So 2 times 3 is 6, and then I have 11 left in the radical. So 6 square roots of 11 would be your answer. Okay, looking at this next one, we have the ratio of the width to the length is 16 to 9. And it says that the width is 32. What is the length? So we're going to use these two ratios to solve, well, it asks for the length of the diagonal, but first we need to find the length of the side. So we're going to use these two first. So 16L equals 288. And then if you divide by 16, your length is equal to 18. So now we can find the diagonal. The width was 32, the length is 18, and we don't know the diagonal length. So 32 squared is 1024. 18 squared is 324. If you add those together, you get 1348. And then you can take the square root of both sides. And I get a decimal. So I want to factor this instead. So 1348, I think it divides by 4. It does. And so 2 and 2. 337 doesn't divide by anything. So instead of writing the square root of 1348, I'm going to do 2 times 2 times 337. And so these 2's will come out, and then I'll have 2 square root of 337 inches for the diagonal length. So hopefully that helps you a little bit with figuring out how Pythagorean triples work and how to use Pythagorean theorem and simplify with radicals. All right, so this is the challenge question. So I want to see if y'all can try this part A and B by yourself, and then we're going to have a C and D after this to go over. So y'all pause the video and try this one real quick. Which of the three would represent the largest value for m equals 5 and n equals 2? Well, if you plug them in, this m squared plus n squared is going to be the biggest one. Is it always true? Yes, it is always bigger. This one, you're taking m squared and you're subtracting n squared, so it's never going to be bigger than this one. And then if you are taking m and n and just multiplying them and then multiplying them by 2, m squared plus an n squared is always going to be bigger than just multiplying your two numbers by themselves. Okay, so now we're going to look at part C and D. All right, so y'all try C and D, and then once y'all are finished, unpause the video and I'll go over it for you. So for C, we want to show that the expressions follow this a squared plus b squared equals c squared. So this is going to be your C because it's always going to be the biggest one. So m squared minus n squared is your A, and then 2mn can be your B, and then your C is m squared plus n squared. So you're going to plug that in, and we're going to distribute over here. So m squared minus n squared times n squared minus n squared would give you m to the 4th minus 2m squared n squared plus n to the 4th, and then plus 4m squared n squared. And on the right side, if we change this to a plus sign, we can just use it for the right side. M squared plus 2m squared n squared plus n to the 4th. Whoops, this should be m to the 4th. And then from here, need a little bit more room. These two terms, here and here, can combine, and we'll have m to the 4th plus 2m squared n squared plus n to the 4th. And that's exactly what I have over here. So that's how they follow Pythagorean theorem. And then you want to use the expressions to find 3 sets of Pythagorean triples. Basically, you're just going to plug in numbers for m and n. And it wants to know, are they primitive triples or are they multiples of a primitive triple? So a primitive triple would be 3, 4, and 5. A multiple of a primitive triple would be multiplying these by 2, so 6, 8, and 10. So that would be a multiple, and this would be a primitive. But basically, just pick two numbers for M&M, and you plug them in, and that would give you your Pythagorean triples. So your homework is 1 through 30, so make sure y'all do those tonight so we can go over any questions you have tomorrow.